I'm on page 300 of New Wider World. Okay, chapter 18, coasts. Pretty quick, pretty simple stuff. This won't take too long. Again, just another definition here. Okay, the coast is a narrow contact zone between land and sea. Now, this is the word dynamic. Well, I would put dynamic in here again. It is constantly changing due to the effects of land, air, and marine processes. Marine processes, that's our waves. So you can add the word waves out here if you want. I'll write waves. Okay, the air or the wind. So I'll write wind. And then what do we mean by land? What we actually mean there is the geology of the area. In the previous video, I mentioned about these very soft mud-like cliffs on the east coast of England. All right, so the geology again also plays an important part. Okay, and we look at that much more when we talk about the Bahamian coast, because obviously our limestone can get eroded in very easy manner. Okay, so the dominant process is the action of waves. That is the big one that shapes and reshapes our coastline. Waves are usually created by the transfer of energy from the wind blowing over their surface. Okay, so waves are created by wind. The stronger the winds, the bigger the waves. Okay, but there's also another factor as well. All right, it's about the distance that the waves travel. Okay, so if you have waves that are traveling over a huge long distance with a wind blowing over them, they will tend to increase in strength and size. Okay, so the larger the wave, the more energy it contains. Simple. The largest waves are formed when winds are very strong. Simple. Blow for lengthy periods and cross large expanses of water. So that's very important. Okay, so if you have strong winds, that's grand, but if they blow across the ocean, the same stretch of ocean, for long periods or a large expanse or a long distance, the waves will then get bigger. Okay, so the maximum distance of water over which winds can blow is called the fetch. Okay, I put a little 1 beside here, and you'll see right at the top 1. A longer fetch equals bigger and stronger waves. A shorter fetch, slower and weaker waves. All right, so again, the fetch is the distance or the expanse, the amount of water that it's blown across. So for example, between New Providence and Eleuthera, if you had winds blowing across that, okay, that's just a short bit of water. You're not going to get massive big waves. But if you had winds blowing across the North Atlantic Ocean from Africa over to the Bahamas, that's an ocean stretch of 4,500 miles. Okay, so it's a huge amount of time and energy. All right, right. We want to just move down the page a little bit here. All right, where are we? So, what happens in a wave then? All right, water particles within a wave move in a circular orbit. So they move with the wind. As the wind blows across the top, okay, it starts a circular motion, which we'll see in the diagram below. However, when a wave reaches shallow water, the velocity at its base will be slow due to friction with the seabed. So once it hits shallower water, okay, there's friction with the seabed that wouldn't have happened out deep in the ocean. So the base will begin to slow down. All right. The circular orbit is changed to one that is more elliptical, more kind of like a rugby ball or American football shape. The top of the wave, unaffected by friction, the surface of the water, becomes higher and steeper until it breaks. And that's where our crest comes in. So if you ever wonder why waves break, okay, and why why it gets all white and foamy, the bottom of the wave, the bottom of that circular motion is getting slowed down by friction with the seabed. The top isn't slowing down, so eventually it'll catch up in itself and it forms a crest and it breaks. Okay, now here we are, keywords: the swash and the backwash. Okay, the swash transfers energy up the beach, the backwash returns it down the beach. Okay, so let's have a little look at a diagram just here. Okay, so again, you can see our circular motion out in the ocean. All right, as it gets shallower, here's the seabed. Okay, as the water gets shallower, see how it changes from a circle into this kind of elliptical shape. The friction occurs along here where the water is dragged across the seabed. There is no friction, or very much less friction along the top. Okay, so you could add that if you want. Less friction flat surface. Okay, so the top of the water, the surface is moving faster, down below is moving slower, so eventually it falls over, okay, and it breaks. Then what we have is, when the wave breaks, water is pushed up the beach. So I want you to highlight this. Sorry, I should have highlighted that. Water rushes up the beach as swash. Alright, so that's what swash is. It's that when the wave pushes material up the beach. Okay? Then, obviously, that has to be pulled back down into the sea. Again, I'm sure you've all walked through this in your days. On the edge of the water. Water from previous wave returns as backwash. It's dragged back down. So if you have a strong swash, that pushes material and sand and rock and all up the beach. If you've got a stronger backwash, it drags material away from the beach. Alright? Just below here again, you've got another little diagram of constructive and destructive. Okay? Now we don't need to sketch them because we've got these two and the ones from the PowerPoint, but I do want you to highlight these so you're aware of where they are. Okay? Back up to the top of the page. Constructive waves and destructive, just highlight those again. It highlights some of the some important bits. So constructive waves have limited energy. Alright, they're slower and they're lower. Most of this is used by the swash to transport material up the beach. So when a constructive wave breaks on the beach, nearly all of its energy goes in pushing material up the beach. Alright? Its backwash is very weak. That's why it'll break onto the beach. It'll use all its energy to swash and push up the beach, drops all its material because it's losing energy, and then its backwash is very weak. It can't really erode away the beach. Destructive is the opposite, full of energy. Most of this is used in the backwash to transport material back down to the beach. Alright? So what happens with our destructive is, because they're higher and they're faster, okay, their break is much more vertical. Let me just show you this just here. Okay? Notice how our constructive wave has a kind of a flat break, and it kind of goes, it breaks and then pushes up. The destructive, okay, because they're going so fast and they're so high, it breaks almost vertically. There's very little swash. So it's almost like a scoop taking material back out into the ocean. Okay, so destructive wave will break much more vertically, very little swash, and it takes material away. Alright, so on that note, we're going to finish with just a little bit about erosion. So erosion. Waves can erode the land by four main processes. Now, these are a little bit confusing, but you have to know them. Okay, we got corrasion and corrosion. They're quite similar. I usually use these phrases, abrasion and solution, instead, because they're more different. Alright, so you've got the definition for each one there. I suggest you make a note of these four. Okay, abrasion, attrition, solution, hydraulic pressure, or it's sometimes called hydraulic action. This one happens everywhere. You will always have hydraulic action. Where you have waves, you will always have it. Going forward in coasts, this will be your go-to erosion. So if ever I say, oh, how are headlands formed? You'll say, well, erosion through hydraulic action, and then you can see which other ones match. But hydraulic action is just the force of the wave compressing air into cracks in a cliff. You'll always have, wherever you have waves, you'll always have hydraulic action occurring, okay? So again, just make a little note of those four, and that is our lesson done for today. There's no assignment, alright? And just make sure you got your notes down about the processes, constructive, destructive waves, and our erosion. Good work.